Hi everyone, welcome to the December meetup of the Sri Lanka DevOps community meetup. Uh, I'm happy to be speaking today on how to decide on a compute service on Azure. I will tell a little bit about me. I'm Marlin De Silva. I am a MVP for Microsoft Azure and currently working as a senior consultant at Capgemini Netherlands. To give you a little bit of context on what are we going to speak about today, the scope of this presentation is about identifying what are the actual compute services you can use. If you look at Azure, there are hundreds of services that you can use. Some can be for logging and monitoring, some can be for networking. The security aspects are there. So quite a lot of things come into mind when speaking about multiple services available. They do serve different roles within Azure. But for the session today, what we are going to look at is the compute service. Specifically, if you build some sort of code, and if you need to host it on Azure, what are the options are available? Some of the decision making that you need to do in order to host in somewhere else, somewhere on Azure. These decisions will be based on quite a lot of things. It can be based on different scenarios. So if you write the same uh, solution, it can run on VM sometimes, on app services, on different services based on quite a few things. So don't take everything to be granted on this session, but I'm going to show you a few things that might be considered when you are going to do it. So speaking of the solutioning, when you think about going to cloud, of course, the aspect of building something new is always there. You can start thinking, okay, I'm going to write this new piece of code on cloud, and it's going to be on cloud from today onwards, starting from today. So I will be starting everything based on cloud. I will assume it will run on cloud and so on. So that option is always there. But a few things that you need to understand when migrating an existing Azure workload is how are you going to migrate an existing solution to Azure. That is where these 5 R's of rationalization come in. So basically, if you have something on-prem, it can be an on-premise server that is hosted somewhere in a server, and now you need to take that onto cloud. You think you need to get into Azure. So how are you going to migrate it? Are you going to rewrite it? Are you going to just rehost it, refactor, re-architect, rebuild, and replace? So these 5 R's are one of the decision making things that you do when you are going to do a migration. So we'll speak about a little bit about this migration side of things, and towards the later of the session, we will think about building new solutions and how are we going to make that decision out there. So I'll start with 5 R's rationalization. To start with, we start with rehost. Now, what is rehost? It's also known as lift and shift migration. So it could be something that you might have a application running on IIS site on somewhere. Now you need to do a very minimal change to it, and you might have very limited time for it, and you might need to bring it into cloud. What are the reasons? Might be that data center is shutting down. Might be the partner who is hosting that data center is not interested in hosting, and the contract might expire. So in such situations, you might think that if a solution is not that really important to be rewritten, and if it is working as it is, and there might be scenarios where the team who is currently involved with the team, the development much don't know much about that solution, so you have the option of rehosting. So what it happen is you will, for example, you can think about it, it's running on a VM on some sort of a data center, and now what you are going to do is you are going to take that VM as it is and create a VM on Azure itself and set up a site on it, put the solutions folder in it, and set up all the networking and everything. So this is called rehosting, also called lift and shift migration. So what drives this rehosting decision? First of all, reducing capital expense. You might be running it on legacy .NET version or a Java version. So if you find the same VM supporting that on Azure, then you have the option for hosting it. I can give you one example that we recently did was a Windows Server 2012 application that was run on a server. We had to migrate it to cloud. It was classic ASP pages, very old. So what we had to do was we had to spin up a Windows Server 2012 and a very old IIS 6 version or so on, and then host that one there. So the capital expense is quite so low. The whole process took us about 2 days to migrate that application. Once you move the application, you set up the configure connection string, ensure the network access is there. That's it. And then, as I earlier said, you might need to free up the data center space. Now, your current data space center might need to be freed up. As I already said, it can be because of contract expansion, contract termination, or it can be due to some other applications need to be done and they are moving away from that OS. So such situations can be a driver as well. And then achieving the rapid ROI on cloud. For example, if you look at a 10-page application, you might take about 20 to 30 days to run that application, build that application from the scratch, because you need to get the requirements, you need to understand what is going on, and all of a sudden, if there are business users, they might ask for some modifications on that. If you are just rehosting it, nobody will notice. Just you set up the Azure VM, host it on IIS, just change the DNS mapping or whatever the other network mappings once the tested. So it's just a very simple thing. So what are the analysis factors? VM size, you need to understand the VM size, CPU, memory and storage requirements, and then the networking traffic, because you need to understand how the networking happens. What are the databases it connects to? What are the other monitoring solutions that it can, there can be some SaaS applications on cloud that it run support with, and there can be some APIs, and then the asset compatibility. As I said earlier in the example, it was a classic ASP site. So how much compatible is it on the modern cloud? Does it allow it? So things like that you need to uh, understand. Then tolerance for change, business priority, and critical business events and process dependencies. Those factors need to be identified, because if something has a critical business priority, it might be a good situation that you modify this one rather than just rehosting it. It depends on how it's needed. For example, if it is something very simple like a timesheet system or time tracking system or something like that, then it's not a very business critical thing to modify it, because the same things that you do will be there forever, so it's not needed. So things like that, if you are looking at a very fast migration, the rehost will be the easiest option. And then we have the refactoring option. What is it? So basically, when you are refactoring, you are looking at pass options to reduce operational cost with migration with many applications. So it's a good idea to going from infrastructure as service to pass service, because then you will have short amount of things to manage. You won't be managing too much on the networking. So if you look at the OSI layers, you will be managing very limited amount of things if you go to pass. So the common drivers: fast and short updates, code portability, and great cloud efficiency with resources, speed, cost, and manage operations. So, for example, if you look at web apps or something like that, you can easily host something that is compatible in there. So, if you have very old ASP.NET application, ASP does not support, or you might have some Java-based JBoss application, you can easily put it on Azure App Service and run it. So, you have the quantity analysis factors. You can select which app service plan it needs to be, and the network traffic and so on. So those factors you can always think and make that decision to refactor it to a past application. So another thing is re-architecture. So what it does is, now if you look at a old monolith application, it can be having all the solution logic that is available in there, but you might need to think about something much more different, like re-architecturing. How do you do that re-architecturing? So you might need to think about bringing more cloud capabilities. For example, containerization. Or for example, you can think about logging on application insights using the configurations or with the application configuration. So situations like that, you can think about re-architecturing the application if it is not compatible on the cloud. So you can use the cloud services that are around it and get the benefit of having them. So, for example, as I said, the configurations, password, and all these things can be in key vaults and app configurations and so on. So, what does drive re-architecture in it? It's not one thing we need to say is it's not just about it. If you need to make it more microservices like that, that's also possible. But in general, what it means is you leveraging cloud services that are available rather than going with the solution based on what it had earlier. So what are the common drivers? The application scale and agility, easy adoption to new cloud capabilities, mix of technology stacks. So if you have a very large application and you need to adapt it to the current cloud frameworks, then you can think about re-architecturing the application. And also it drives things like the DevOps way of working, so you can think about more cloud native solutions that are given there. And then we have rebuild. Yeah. So what does rebuild comes in with? So rebuild means uh, it means you are going to rebuild the whole application that was having whole majority of the part of it. There can be part of the code that you can reuse, but still you are going to change it. For example, as I already said, one good example would be you have this monolith application and now you need to make it a microservice based application. So you are going to convert it to a microservice based application and use the cloud native support things out there. You can use Dapper, you can use Service Bus. Things like that make the application stay more connected with the cloud. So, what are the drivers into the rebuilding solution? It comes more about innovation. If you need to think about new way of working or splitting the application that's there, and then rebuilding applications faster. For example, you might have a very big application that has quite a lot of epics inside that if you look at the DevOps way of working, agile way of working. So you might need to start with bringing one by one epic into this new application. You might have part of it in the old application, but you need to bring them into new applications. So in such situation, rebuilding would be very good. And then there might be some operational cost having the old application as it is. For example, one thing that we recently spoke about was having a very old technology on there, something like COBOL. If that application is running on COBOL, then you might not find much of professionals who are aware of COBOL. So the operational cost is too high and it's too risky to keep it like that. So you need to uh, think about it and do a rebuild. And also there are some qualitative analysis that are interesting. For example, if the technology is too old, it will have declining end user satisfaction, and if application is too rigid for the changes, then the business process might be limited by the functionality that it provides. For example, if business wants a change, you might not be able to provide that change as it is required. Then there might be potential cost and experience or revenue gains that you can do by rebuilding the whole application. Last one is replacing. So in replacing, you might or might not consider too much about whatever you have currently, but what you are going to do is you are going to replace it with something totally new. For example, you might have WordPress application customized on somewhere, hosted somewhere on a data center, but you might think about going with the SaaS offering on Azure for WordPress. So what will this do is this means you are not thinking about writing too much code. You are much reluctant to write the code, but you are more interested in you leverage something that is already in there. So it might be easier to use a software as a service in this situation. Something the reasons can include the cost benefit with the current architecture versus the SaaS solution, business process maps, data schemas, and custom or automated processes that are in the place. So like this, the 5 R's are all about migrating an existing workload to the cloud. So you might think about rehost, re-architecture, rebuild, or replace, or any of the options that are available. And I would like to go about a few examples that we need to think about, we can consider when going to cloud. For example, if you have sort of a, this can apply to an existing application as well as totally new application. Now imagine you are going to build a containerized application. So if you are building containers, there are multiple places you can host these containers on Azure. One is the app services, right now called its web apps, and then Azure Kubernetes services, which is full-fledged container orchestration available. And then Azure Container Apps are there that comes with networking plane on top of the Azure Container instance, which is not listed here, but it's also an option. So why would you think about containerizing the application first place? Well, containerizing is providing portability for you to host in anywhere. So you are not locked on the vendor, you are not locked on too many things. You can build all the information around the environment you need along with the package. So if this thing worked on the dev, it works on test, it works on production. So some sort of a thing like that containerizing brings with you, allowing you to take the configuration with the application code itself. Now you can host that in app services. You can start with app services if it's a web app that is available. Why it is easier? It's fast time to market. You can easily build it and host it there. You don't need to set up too many things. You just need to have a container registry on Azure or even Docker one, and then set up the command to trigger it. It already has all the public IPs enabled, so if you can use the IPs as it is, so the networking is not much of an issue. You can set up it very easily, and you can easily scale it with the limitations of to the number of maximum instances you need. And you need to know very less knowledge on the container orchestration, containerization. You can create the container, but you don't need to know too much of things about containerization. But looking at the long run, if you're starting an application that thinking this will be moving on to containers, and if you might think about Kubernetes on future, but you don't have the expertise right now, you can start with app services, with apps anyways. And it provides the option to ease of switch away from containers. If you need everything is there, if you think about going back, which is unlikely to happen right now, but you can run the full-fledged code itself as well. Just need to change the runtimes on the configuration. And then we have the Azure Kubernetes services. So it allows you the full-fledged orchestration. You can run multiple containers within a environment. So that means the compute nodes are very closely located. You can have very low latency design within the application components. You can customize the scaling to number of pods you need to expand based on the request or whatever the parameters you need, and you are less vendor bound. So you don't need to, if you think about hosting this Kubernetes service on a different vendor, you can easily move it without too much issue. Or going to on-prem with the Kubernetes service, yes, you have that control as well. And then one of the latest versions of introductions of Azure is the Azure Container Apps. So what does Container Apps does is it provides you the Kubernetes container featuring facility without giving too much complexity to you. So the complex concepts that are available in Azure Kubernetes services, they are pretty much simplified and given with a control plane. So you can play with the Azure control plane rather than going to command line and thinking about too much management of the nodes and pods and so on. So you should basically create a container apps environment and host containers apps inside it. Within that, you can define how to scale in, scale out. You can define ingress and egress within an application. So all the options are there. It's scalable with limitations. I think right now there are certain limitations into maximum number of scaling it can do and so on. And then the environment level limitations certain are there. But it's, if you are thinking about getting started, that's a good place to get started as well. The only main difference between the app services and container apps is that container apps are built to run native containers, whereas web apps are built to run multiple things, including the full-fledged code in there. And one other thing is, one other famous example is APIs. Now, when we think about APIs, we can think about multiple ways of hosting it. There are multiple options available there, but I would like to think about comparing two of the options available there. First one is the Azure Functions. So Azure Functions are meant to run very short amount of code executions that are event driven. So HTTP trigger is one of the triggers that is available. So if you need a HTTP trigger, you can create a HTTP trigger which will be exposed as API endpoint to outside, and it has certain execution time limitations in the starter, the basic functions. It's like 90 seconds, and then it goes to 5 minutes in the premium plan and the app service plan. So the execution time limitations are there. Basically, you don't have too much control onto the API, and it's easy time to market. You can even create a function on the Azure portal itself. So it's very easy to create Azure function. Another thing is that within a single function application, you can have multiple triggers. So if you are having the HTTP trigger, you can have a service bus trigger as well. Yeah. So if you are thinking about creating a domain based architecturing, you might be able to have multiple components related to the same domain within a single function, and HTTP trigger just be one of them, and they can be exposed to outside via APIM or something like that. And then the container apps are there. One thing that is very good about the container apps is the scalability. We spoke about it in the last slide. But overall, it also comes with the Dapper sidecar. That means if you are thinking about APIs, but then your endpoint is there, and then you are thinking about dividing the workload between the pub subs, that option is also there. You have the Dapper sidecar, you just pub and sub there. So those options are always there. But these are not just depending on the compute desires that you have. So there are quite a lot of decision factors that are coming. I will I will speak about them, these three highlighted areas. First thing is the organization service catalog. Now, in most of the regulated environments, the There is organization service catalog that is allowed you to create certain apps, certain services on Azure. So you are not allowed to use all the services that are available. So for example, they might not allow creating apps, web app instances for some reason, because usually what happens in a highly regulated environment is that there is a security validation that needs to be done, quite sort of thing that we need. And then also, even if you create, you might not get the scaling that you need on there. So the organization service catalog will play a key role in when you are doing something related to the your decision making. And then the latency. So depending on your solution structure, there might be some latency constraints. For example, if you think about building a globally distributed application, you might have different uh, scenarios where you need to distribute across different regions. So in such situations, if you have 5 regions, it will be much easier to deploy them to Azure Web Apps rather than managing 5 Kubernetes clusters. So situations like that play a role in the decision making. And then always come with the regulations and compliance requirements. There can be some industry-based regulations and compliance like financial services. There can be some country-based or country or region-based regulations and compliance requirements, such as EU or Australia or something like that. So internal decision factors will decide what are the services you can use. So basically, before making any decision, it's really important that you have an understanding on the service catalog, what's allowed and what's not allowed, and what are the levels it is allowed. For example, if you look at VMs, there are multiple classes of VMs. But if you look at certain situations, there might be some classes not allowed. For example, if you think about confidential computing nodes, they might not be allowed. But if you need to use the confidential computing features, and if it is not allowed, that VM you can't use there. So such situations are really important to understand based on the situation you are in. And one last thing want to show is this general compute decision tree. This is provided by Microsoft. We will go through it a little bit and see how you make the decision. Now, this is something that Microsoft has provided as a general computing decision tree. It has all the situations, but if you are an organization and if you need to make something like this, you can think about what are the options we have and how we make that decision tree. Usually, a cloud center of excellence has that. So that cloud center of excellence will guide based on this decision. We recommend going through this like that. Now we spoke about migrations earlier. If it is going to be a lift and shift, you can think whether it can be containerized or not. If you cannot containerize, whether it's a COTS app, yes, COTS mean client, you don't have access to source code. It will be a virtual machine. You can host it in virtual machine because you don't have the option of customizing it. And if it is not, and you have the access to source code, if it is on Spring framework on Java, you have the Spring Apps option. Otherwise, you have the Azure App Services option to host it out. And if can be containerized, then it goes through this way. We will go through that and so on. And if it is a new application or if it is already cloud optimizations, then you can make decisions there. If you are building something new and if you need full control, what does full control mean? If you look at the OSI layers, it starts from the memory to everything. You can use virtual machine, which is the infrastructure as code option. But usually most of the organizations are now going away from the virtual machine. So unless it is very critical for you to have it, then it's recommended that not to go with virtual machines. But who knows, there can be situations where it is required. If you don't need, and if it is a high HPC workload, you have the Azure batch services. You can run batch services there. So you will be using compute nodes, but you will be interacting with the control layer on the batch services. And if it is something like using Spring Boot, you have the Spring Apps capability, which is always there. And then if it is event-driven workload with short-lived processors, so if it is a HTTP trigger, it can be a service bus trigger, it can be a newly coming SQL database trigger or a Cosmos DB trigger. You need, if you need any of these, you have the option for using the Azure functions. And if you need managed web hosting, then the Azure App Service is there as an option as well. If you don't need any of this, you have the container instances. And if you need managed full-fledged orchestration, you have the Kubernetes on Azure VMs and OpenShift on VM. And if you need some Service Fabric or older .NET frameworks, Azure Service Fabric is there. If you are preferring to use Red Hat OpenShift, Azure Red Hat OpenShift is also there. If you still come through all these things, and if you think you need to have access to Kubernetes API and have a very well managed containerized structure cluster there, you have the Azure Kubernetes service as it is there. Otherwise, if you don't have need to access to API, let Microsoft take care of it, and you don't need anything like that, then the container apps also option is there. So also there are several options that are listed down here. For example, container compatible services, Azure Batch Functions, Service Fabric, Spring Apps and App Services, they are compatible. And also there are certain container exclusive services as well. Yeah. So like that, multiple options there for you to decide which one you want to choose. And as I already said, usually an organization has its own compute decision tree with the recommendations on which ones to use. So this is a very general one. If you are trying to go with something, you might find this useful, but if it's in an organization, usually you need to have your own ones, because not all services will be necessary for organization. Okay. So that's it from me. Thank you so much for attending. And if you have any questions, just reach out to me on LinkedIn or Facebook or Twitter. Yeah. Thank you.